Hi, I came across this question from Socratic.org, and this question is about mixing volumes. So you've got two different solutions, one of 2% and the other one of 7%, and they're both acid, and they must be mixed to get 50 pints of a 5% solution. Obviously, it's a straightforward problem. There are different ways of solving it, and I'm going to use the Microsoft Excel way to solve this problem. Okay, the first thing you need to know is what is concentration. So concentration is mass per unit volume. So concentration is mass per unit volume. So it can be written as C is equal to M divided by V. And what it means is that the mass is the concentration times volumes, and the mass must be preserved. The mass must be balanced at all times. So whether I'm starting with some mass, I should end with that mass. Matter cannot disappear. That's the law of conservation of mass. So that forms the main basis to solve this problem. So concentration is mass per unit volume. That's what you need to remember now. So let's go into Excel and how we can solve this problem. So here we go. We are in Excel now. So this is Excel 2013. So I just wrote in the form of a table so that we can name some of these cells. So what I've done is I've got the first asset. You can see in here in the top left hand corner, it's called asset 1, and the 7% solution is the asset 2. So just when I click on the cell, it says asset 2, and that's the mixed acid concentration. You can see it better here. So mixed acid concentration, that's 5% that you need, and you need a total volume of 50 pints, and I've got the units here, pints. And I've also got volume 1 and volume 2, and this is where you would put in the volumes if you need to find either the mixed volume or the volume 1 given volume 2. There we go. So we've got two unknowns, which is the two volumes of the acid 1 and the acid 2, and we can write two mass balance equations. So the first one is we need a total volume of 50 pints or milliliters or liters, doesn't matter. So as long as the consistent unit, it's fine. So that means the volume 1 and the volume 2 must add up to 50. And then the second one is, as we saw earlier, the mass is equal to concentration times volume. So we've got the concentration is here and the volume here. So that means when I multiply these two, concentration by the volume, I get the mass. That means the mass of the acid 1 plus the mass of acid 2 must equal to the mass of acid. That's what I'm doing here. 2 times the volume 1 plus 7 times the volume 2 gives 5 times the volume, the final volume that we need, which is 50 pints. Okay, so don't be put off by this tables. So I hope you will be able to learn how to make these formulas in Excel, which will be very useful if you're studying science or mathematics in your A-levels or even in engineering. Or doesn't matter really, anything where you use mathematics. So what I've got is, so I've got two equations and two unknowns I would like to solve it. Obviously you can use a graph paper to solve it. You can solve it algebraically. You can substitute for volume 1 in the second equation, and you can get the answer. But I would like to take Excel way to find out the solution to this problem. So as you can see here, everything is a formula based here. You've got here volume 1 and volume 2. They're all actually formulas which is written here. So volume 1 plus volume 2 equals 50. So when I look into the formula manager, it says F4, which is here, which is this one. I'm adding a plus sign. That means to concatenate using the ampersand sign. And F5 should be equal to volume needed, which is the 50 milliliters. So like that, I've made these equations. I'm not going to go into the basics of constructing an equation using the concatenation operator ampersand. So I'm just constructing a few data points. So I've got all the way up to 50 milliliters here, because that's what we have. We have a total volume of 50. So when you have acid 1, it can be the 50, and acid 2 has to be 0. If it is acid 1 is 1 milliliters, then the acid 2 must be the total volume, which is 50 milliliters minus the volume 1. So that's what I've done here. So I have consistently kept the total volume 50 by using the volume of 1 to find out the volume of other, because we know the total volume. So that would be this equation. Volume 1 is equal to 50 minus volume 2, which is what I've got here. So the second equation is, so I'm going to use this equation here, the mass balance equation. So when you look into here, so what I've got is I've used a round function to have up to just 1 decimal places. So what I've got here is the right hand side, which is what this one. So volume needed times mixed acid concentration, which is the 5 times 50. And then this 2 times volume 1 would go on the right hand side. That means you're subtracting. So that's what you've got, a subtraction operator there, multiplied. The acid 1 concentration multiplied by the volume 1, which is this bit here. So then divided by, we need the 7, which is the concentration of the acid 2. So when you do that operation, you get volume 2 as the unknown. So then you write the equation and then you double click and send it down, and then you can see that it has filled in all for the same volume 1, the volume 2. So you've got, so now I've plotted them into a scatter plot, and you can see that they relate very nicely, the volume 1 and the x, the volume 2, because they are both related by the linear equations here, the two equations. They're both linear equations. So it's not surprising that we get a linear plot, and then they nicely intersect at one particular point here. So which is, so the x-axis is volume 1, the y-axis is volume 2. That's exactly one point they intersect, and that intersection point gives you the volume of acid 1 and the volume of acid 2 needed to make the final volume of 50 milliliters of 5%. So then I've also written some more equations to represent answers like this. So what I've done is at some point you can see that there is one particular value of volume 1 where the volume 2 is the same for both the equations, and that's what I'm comparing here. So I'm looking at the volume 2 from the first equation, and then I'm asking, is that equal to the volume 2 from the second equation? So as you can see here, that's what I'm asking. It's using the equal to operator. That means I'm asking, is the volume 2 from the equation 1 equal to the volume 2 from equation 2? And then I say, obviously, that's 49, that's 35, they're not equal. And then when I keep going down, and then I put in a conditional formatting to say, oh, there's one point where they are equal, which is 30. That means when the volume 2 is 30, that means volume 1 has to be 20 because the total volume is 50. So that's what the answer is. And this merely uses some functions in Excel called index, and it gives you the answers for the volume 1 and the volume 2. So let's take some other concentration here. Let's take volume 1, the acid 1 concentration as 1, and then the acid 2 concentration as 6. And you can see we get new volumes and a new set of straight lines here. You can see it there. Okay. What about if I change the total volume? Let's say shown total volume is 80 milliliters now. So you can see, everything is updated automatically. The volume 2, the volume 1, and obviously there's one place where it will be equal for the same volume 1, and the straight lines are also different because the slopes are different. Okay, so I hope you get the gist of it. Using mass balance and a bit of Excel, and it's pretty straightforward solving simultaneous equations to find out the volume of mixing solutions. So good luck, and I hope you try it. And if you have any questions, do write to me. I'll be posting this spreadsheet on my blog as well. Okay, so good luck.